Welcome to section 6.1. All right, chapter 6 was all about random variables. So we started talking about discrete and continuous random variables here. Discrete random variables have a finite number of outcomes with gaps between them. So if we're talking about number of heads, if I flip a coin 3 times, 0, 1, 2, or 3, I can't get 1.6 heads. I create a probability model or probability distribution. The probabilities have to add up to 1. They all have to be between 0 and 1. Been there, done that. Okay. I could create a histogram of the probabilities. I could describe the histogram. Nothing new there. Now, what they will ask you to start to do is, can you find the expected value or the mean of the discrete random variable? Can you find the standard deviation of the discrete random variable? And there's formulas for that, which we touched upon here. So the formula is essentially, it's a weighted mean. So I'm taking each value times its weight or its probability. And it ends up being this. It's the sum of the value times its weight, or the sum of the value times the probability. This is on your formula sheet. Let me grab it. It's right here to show you. Discrete random variable. Oh, hey, that's what we're doing. Mean of x or the expected value of x. Take the sum of all the values times the probability of the value. That's all that's saying. So we got that. All right. Here's an example. You take a look at all these values times their corresponding probabilities. If you sum this whole thing up, you get 8.128. If it's a short answer, you have to write out this work. But remember, like I said in class, plug the value in list 1, plug the probability in list 2, and then you want to run, I'll show you on the calculator because it's right here. You want to go to calc 1 variable stat, list 1, list 2, and calculate. I just, there's some data in here, it's not the right data. And that would be your average or your expected value. Okay, standard deviation. We know standard deviation is the distance from the mean, the average distance from the mean. So what we're going to do with this formula, it's a lot more intimidating, but let's work through it. I'm just going to take each value minus the mean, square it. That's the distance from the mean. We square it because otherwise, if we didn't, we'd end up with a sum of 0. We're taking all those squared differences, adding them up, and then multiplying them by their weight. So for this question, same data, we have to get the mean, which was the 8.1. So I take 0 minus that, that's the distance from the mean squared, times its weight, the probability, plus 1 minus the mean squared times its probability, so on and so forth. This would be a nightmare to type in the calculator. You're not going to do it. You're going to do what I just showed you a minute ago, and lo and behold, that would be your standard deviation. Again, I don't have the right data in there, but the process is what it was. But if it's short answer question, you're going to have to write out a couple of these, ... They found the variance and they're taking the square root at the end. Whether you take the square root here or do that and then take the square root, doesn't matter. So for a discrete random variable, you need to understand how to calculate the mean and the standard deviation, and then the interpretation. So where is this? Yeah, right here. Okay. All right. A large dealership keeps track of how many cars they sell. Okay, we did this question in class, I think. Interpret the mean. Well, the mean's 1.1, and this is going to incorporate the law of large numbers. If many Fridays are randomly selected, that's the law of large numbers. Then the average number of cars sold will be about 1.1. They're never actually going to sell 1.1 cars. It's impossible. Like, they're not cutting the car in tenths and being like, hey, here's the bumper. Have a nice day. Number 2, compute and interpret the standard deviation. The number of cars sold on a randomly selected Friday, one randomly selected Friday, will typically vary from the mean by about 0.943. So that's what we've known it to be. The mean, the expected value, that's, you have to include the law of large numbers as part of that, like over the long run. Then we transition to continuous random variables. For continuous random variables, the difference here is you can have an infinite number of outcomes and there are no gaps between them. So things that you measure, height, length, time, those would be examples of continuous random variables. So in order to deal with these, we need to talk about a density curve. whether it's a uniform density curve or our good friend, the normal density curve. And then what's really nice is this ties into stuff that we know and we're confident with, hopefully, is we would calculate some z-scores and then use normal CDF to find the area under the curve. Okay, so that's it for section 6.1. There's two main types of variables we talked about: a discrete random variable. There's a finite number of outcomes, and there's gaps between. How many children do you have? 0, 1, 2, 3, 4. Continuous random variable. How long did it take you to walk from school to home? Anywhere between 0 and 30, 40, 50 minutes, whatever it is. It could be literally any number between 0 and 50 minutes. That would be an example of a continuous random variable. All right. So hopefully that was helpful, and we'll move on to 6.2 in a minute.